Alright, a couple of videos ago we ended up with a solution after dividing some radicals to get 6x over radical x. I'm going to show you now how we can treat that. And the way we're going to do that is by rationalizing a denominator. So the reason it's called rationalizing a denominator is because a non-perfect square is an irrational number. For some reason, whoever wrote the laws of mathematics, they said you're not allowed to have a radical in the denominator. So we're going to follow whomever's rules, and we're not going to leave a radical in the denominator. So going back to our rationals unit, this is not an equation, it's an expression. So if we want to change the value of this fraction, we're forced to multiply by forms of 1. We can multiply the numerator and denominator by the same exact thing if we wanted to change the value of this. If we want to change the look of this, we wouldn't be changing the value of it, just be changing the way it looks. And the way you rationalize a monomial denominator, one term, no plus or minus, is by multiplying by itself. So we're multiplying by 1 here, which means we're not changing the value of it, we're just changing the way it looks. So let's clean this up. 6x times radical x is 6x radical x, and radical x times radical x is radical x squared. We can clean that up and say 6x radical x over x. Finally, we can cancel some x's, giving us 6 radical x, which was the same solution we got on the first dividing questions that we got before we simplified the radicals. So if you go back to the multiplying, dividing videos, you'll see that this was the solution we got. That was a parallel solution with this when we showed the two different methods. So that's just proof that we got the same answer before. It just took a couple of days to prove that that was true. Now, that's for a monomial denominator and only with the radical. What if we had something that had a coefficient? Let's say we had 2 radical x over 3 radical y. How would you rationalize that denominator? So what you have to do is look to see what's giving me trouble here. I'm allowed to have a 3 in the denominator. I'm not allowed to have a radical y in the denominator. So that's what I'm going to multiply by. Whatever's giving you trouble. And I'm going to multiply the numerator and the denominator because this is an expression and I do not want to change the value of it. So let's multiply straight across. Radical x times radical y is radical xy. Just make it one radical. And the numerator is now 3 radical y squared, which now is a perfect square. So let's rewrite the numerator. And let's take the square root of the denominator. And now we no longer have an irrational number in the denominator, so we have accomplished our goal by rationalizing the denominator. So that's for monomials. What about binomials? 4 over 2 plus radical 3, for example. So now we can't just multiply by radical 3, because look what happens here. If I multiply by radical 3 over radical 3, this is a monomial times a binomial, so I'm going to have to distribute. Now, this is not the correct method. Wrong. Don't do this. I'm just showing why you can't do this. 4 times radical 3 is 4 radical 3. Now we have to distribute this radical 3 to both of these terms. 2 times radical 3 is 2 radical 3, and radical 3 times radical 3 is radical 9, or 3. So if you look, we still have a radical in the denominator, so no good. For binomial denominators, you have to multiply by the conjugate of the denominator. If you remember back to last video, the conjugate of 2 plus radical 3 is 2 minus radical 3. So we have to do that to the numerator and the denominator. So let's distribute the numerator. 4 times 2 is 8. 4 times negative radical 3 is negative 4 radical 3. There's our numerator. And let's FOIL the denominator. 2 times 2 is 4. 2 times negative radical 3, negative 2 radical 3. Positive radical 3, positive 2. What do you know? Our outer and inner terms cancel. Positive radical 3, negative radical 3 is negative radical 9, or just 3. So let's clean this up. Our numerator remains the same. And 4 minus 3 is 1. So we could just drop the 1 and say this is 8 minus 4 radical 3. Which means 4 over 2 plus radical 3 is equivalent to 8 minus 4 radical 3. Now the trouble with rationalizing denominators, sometimes you can simplify and find the GCF and cancel here, but the denominator is 1. If this denominator were 2, for example, I'd be able to factor out a 2 and cancel it. Alright, that's a monomial divided by a binomial. What if we had a bi divided by a bi? 1 plus radical 2 over radical 3 plus 1. So this is not what's giving us trouble. It's the denominator that's giving us trouble. So we're going to multiply by the conjugate of the denominator. So stick this in parentheses so remember to FOIL. Radical 3 minus 1. Radical 3 minus 1. Remember, the order is important. It's only the sign in the middle that we're changing, and we're changing the denominator. And we're multiplying by a form of 1. So let's FOIL the numerator. 1 times radical 3 is radical 3. 1 times negative 1, negative 1. Radical 2 times radical 3 is positive radical 6. And radical 2 times negative radical 1, negative 1 is negative radical 2. Ooh, real messy. But that's alright. Radical 3 times radical 3 is radical 9. 3. Negative radical 3. Positive radical 3 cancels. Positive 1 times negative 1. There we go. And we clean it up. Radical 3 minus 1 plus radical 6 minus radical 2 all over 2.